So continue from the previous video. The problem is if we write the for loop condition is wrong, they will access the element out of the array. So that's why we assign 100 through the values 3, values 4. But they actually is already been defined those memory location assigned to X and Y. The reason is you can see in your code, I declare this variable array. Then afterward, we continue to have X and Y. So values array actually only occupies 3 elements. But because C++ don't do the bound check, so if you have your for loop condition is wrong, they still allow you to continue to access the memory location following. So in other words, when you do try to make the wrong condition for the array size, they were using the extended wrong location to occupy the value in other variable. That's why when we display the array again, so you can see here, right, they do access 5 elements. They display this 500. But one thing is only the first 3 belong to the array. The last 2 actually is X and Y earlier we defined. But in your code, you are expecting X equal to 10, Y equal to -10. But here, since you have the wrong condition, then they make your program wrong. Because supposedly earlier we assign X equal to 10. Because your mistake make the array condition boundaries wrong, then they override X and Y. So then in your code, if you try to do some other calculation for X and Y, your output will be unexpected. So that's here why we talk about the no bound check in C++. So that's why in order to fix that, one thing is you need to make sure every time you write your for loop, you need to have the right condition. So that's why we always have the size. So then you can see this one actually is the wrong one because we make our count start from 0, then less than equal to size. Remember, it shouldn't be correct, right? Because the correct way is you need to have your index always start from 0. Then your count, your index should be less than size. So that's why here, let me change become this way is correct way. Instead, in order to make sure when you watch the handout, don't confuse about that. So this way is the correct way. So if you make your for loop condition to access array get wrong, C++ actually don't tell you. So that's why let's go to our next topic. So we will introduce you another for loop. So this for loop we call range-based for loop. This range-based for loop actually is after C++ 11. We provide a specialized version for the for loop. So this for loop actually is range-safe, or we say range-based for loop. That for loop is a loop that iterates 1 for each element in the array. So you don't need to give them the I start from 0 or I less than the size. Instead, you just give them the array name. So in this range-based for loop, they will iterate each element in the array. And each time, they will copy each element from the array to a built-in variable. So this built-in variable actually is later we need to using this variable defined in the range-based for loop. So this range variable will be automatically to copy over each element to this location and process each one. The range-based for loop automatically knows the number of elements in the array because that's from the compiler. So you don't have to using a counter variable for the index. You don't have to worry about if you stepping outside the bound of the array. So that's what we call the range-based for loop. So the range-based for loop, the syntax is look like this. The general format for the range-based for loop is you will still have your for keyword. You still have your parentheses, have some information here. Then after your for loop, your statement can be one statement or multiple statements. If multiple statements, of course, we need to have a braces. So each iteration, we will work the statement in the braces. But here, your syntax in the parentheses a little different. So the first thing, you just need to have your data type. Then this data type declare a range variable. So this range variable is earlier we say the placeholder to save each time the iteration element from the array. They will copy to this range variable. So the variable name actually you can decide by yourself. So then you have a comma. Then you have your array name. So the data type is the data type need to match with the array. So then this range variable will be the same type for each element in the array. So this variable will receive the value from an array element during each iteration. So the array actually is, we say, the array name. So every time what they do is they start from the first iteration, they access the first element in the array. So this first element in the array value, they copy into the range variable. So using this range variable, you will perform the statement you want to do to process each element in the array. So those statements is executed during the array loop iteration. If we need to execute more than one statement, of course, need to have a braces. So this one is the range-based for loop syntax. In order to help you to understand, of course, let's see an array. So we see the example 4. So later you will run this example 4. So in this example 4, the first thing that's declare an array using the initialization. So then you can see here, I don't know the size. So then I just using the int array called numbers. I don't know the size. I just give them 1, 2, 3, 4, 5 element value. So of course, you know they will create 5 elements. So that's why you see, since I don't know how many elements in my array. So one thing is we were using the for range-based loop. So this range-based loop, when we have, remember we told you you have your for keyword. So then you have your parentheses. So then you have this val is our range variable, colon, then that's your array name. So you can either using this data type using the int, because we came from that int array. Or in C++11, we're using afterward, we're using the auto. So this auto will be according to what is the data type for the numbers. So then they will automatically to resize the val element size. So that's why here you can see that for each loop, they just display the val each time. So each time they just have start from the array element first, the numbers array element 10 to copy to val. So then you see they display 10. So then 20 display, the 20 copy to the val displayed 20. So then the same thing, 30, 40, and 50. So that's what we call the range-based for loop. So that's output. So of course we should run on the IDE. So that's why we open example 4 from our IDE. So you can see here we have the initializer. So then here we're using the auto for the val data type. So colon, then you have your array name. So then when we run the program, you can see they display one by one. So then one thing is you can see here, because we don't know the size, we're just using the initializer, right? But then you see here we have 5 elements. So even you change, you have 10 elements. Then you don't need to worry about we don't know the size, because for the range-based for loop, they will automatically to know the beginning and the end for the array. So each time they copy over to the val. So that's why you can see when we run, yeah, they have all the number. So this syntax is very good practice for the C++11 afterward because we have auto. Otherwise, if you want to specify the data type, your range variable data type should match with your array data type. Or you do double. So your range variable can either using match with the array data type or using the auto. So that's both are okay. So you have your output. But one thing is, when we talk about the range-based variable, right? Like earlier we say, they just every time copy over one element from the array to the built-in variable. So that's why they passing by copy. So that's why here, when you try to update the val value, actually they won't reflect into the array. For example, here, we just display the original array, right? So that's 10 to 100. So then we display the first time. So then the second time, you can see here, if I try to update the val value, if I try to update the val value equal to 100, when we run the program, they still just display, right? And also here, they didn't give you the error message. But one thing is we see if we update val equal to 100, will they update from here or not? So that's why you need to display again. So this one, the second one actually is the set. So actually the second array, you will see they only set each val equal to 100. So then we display again from the array, see if they are correct. But here, actually that's at some C out, so we can see different. So we can check they are in different loop. Okay, so that's I just display before each loop. So then when you run, right, so the first loop, we display the number. So that's why you have 1 to 110 to 100. But afterward, you try to update your val value, then we display again. Then you will see here, they didn't change the value to 100. They're still using the same number. The reason is when we're using the for range-based for loop, when they try to do each iteration, they only copy the original value to the range variable. So even your range variable value being updated, right? They just like update the local variable. They never go back into your original array. Because like we say, they only do the copy. So if you really want to using the range-based for loop to update your original value, so you want to modify your array using the range-based for loop, then you cannot using the for loop to modify using the range variable. Instead, your range variable you need to declare as the reference variable. Did you remember last week we talked about the reference variable is ampersand? So that's why here you will see this range variable you just define is auto variable or int variable. So then they will pass in by copy. But now if we make another range-based for loop, but the range variable we define is reference. So like here, we're still doing the same thing. But then if we do the int reference, then they can update the value. So that's in your example 5.